Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your plant and equipment. Okay, so here we are going to see that the how we clean that plant and the equipment which is used in the manufacturing of the milk or milk product. Okay, so basically what we are going to discuss about, we are going to discuss about the methods how to clean the plant and equipments which are used in the manufacturing of milk and milk product. Milk and milk products. We all and even we all know that milk are the rich source of the nutrients. Milk are the rich sources of nutrients. Okay, and when the plant or the equipment used for the manufacturing of this milk, the debris of the milk will be stay in the equipment or even in the plant of the milk manufacturing industry, and this will leads to the growth of the growth of the lots of the microorganism. That's why it is very essential to clean all these debris. So here we are going to discuss about it, how we perform all these activities. So let's start the today's lecture. The type of the factory that handle a milk and milk product ranges from simple labor intensive unit through a highly automated plant. Okay, so we all know that the industry which are manufacture the milk and milk product, or which handle the milk and milk product, they have a higher range. Okay, their range are from a labor intensive unit. That means that the manufacturing occur with the help of the labor, and even highly automated plants are relying on sophisticated unit operation, even under a computer control. Consequently, a wide range of processing equipment, which included the heat exchangers, vats, mixers, and it also container may be needed. But whatever the configuration, every item must be accessible for cleaning both inside and outside. No matter which type of the instrument and which of the configuration we are using during the manufacturing of the milk and milk product. Either we are using a heat exchanger, okay, either we using a vats, mixtures, and even the container which is required for the storage of the milk and milk product. No matter how the configuration, which type of the instrument we are using, which type of the equipments we are using, but the main thing is that cleaning should be done inside and outside both, so that it will avoid the microbial contamination. For example, product which contain a surfaces that should be stainless steel, and cleaning sanitizing regime must allow through a disinfection of any surfaces irregularity. Equally important is area behind or beneath an item of the equipment, because if dust or food is allowed to build up in such crevices, then occasionally incidents of spoilage are sure follow and became sporadic in nature. Okay, so if there is a you can say that if there is if the equipment contain a dust or the food which build up in a form of services or in a form of debris, then it will lead to the incident of the spoilage and also contaminate the product. So the sources of such complaints will be nightmare to identify. Okay, if our equipments are not clear, if our equipments is not proper clean, not proper sanitized, then automatically it will leads to the spoilage of the product, it will lead to the contamination in the product, and ultimately it will lead to the complaint which we get from our consumer. And sometimes this type of the complaint is uh, not easy to identify. For small scale operations, two interrelated pressures can be cause problem. Okay, if we say if we see a small scale operation, then in that case there is a two interrelated pressures can cause a problem. The first one is a investment necessary to get a building and install a new plant. Okay, so first of all we require a investment which are very necessary for building and install a new plant, and also we require the equipment which may not be available. Okay, so for small scale operation we have two challenges. One is the investment and another one is a equipment which may be not available. So equipments. And secondly, a particular process may be a little more than industrial version of a traditional or a village scale uh, procedure. If end result is a hybrid system, they are a part of the industrial and part traditional, then the operator may not be realized that the risk involved in scaling up a process in order to supply a more extensive market. Then the use of the wooden chopping board to a dice low volume, high cost ingredients, especially in the case of the cheese. So, in the place of the because this extension to a industrial scale operation necessity a shift to an impressive heat resistant synthetic surface that will not allow the penetration of food or bacteria. Now the next one is your in a large plant pipe work that must be installed with neither dead end from which food is never removed during a cleaning. Okay, so if we talk about a large plants or a pipe work that must be installed in that way that it does not contain any dead end. Okay, so in that end the removal of the food is very difficult. So that's why during that's why this dead end should not be present nor supported run of a pipe that sag in a center, and it will provide a pool of dilute food for a bacteria or yeast. According to the Home in 1980, if latter situation cannot be improved, then filling the clean and disinfectant plant with the water may be only the option to prevent the buildup of the microbial contamination overnight. So uh, letter the approach which can prove the effective if followed by the sanitization rinsing immediately prior to a startup next morning. Okay, so this approach should be done that sanitization and the rising immediately when we start up the next morning. Before it we have to sanitize and rinse the whole plant so that the microbial contamination will be avoided. Routine also deny insect or rodent entrance to the pipe one. Okay, so we have also denied the entry of the insect and the rodents to enter inside the premises. Okay, or you can say that the pipe works so that it will also leads to the contamination. That's why it is not allowed to enter inside the pipe work. Now the next is your cleaning of process plant. Now, how we clean this process plant, irrespective of capacity of the plant, cleaning is to remove the food residue. Okay, so if we said that according to the capacity of that plant, what is the meaning of that cleaning? Cleaning is simply that we have to remove the food residue on both, that is either inside and outside of each component. Okay, suppose that this is a pipe which carry a milk and milk product. Okay, now we have to clean both side, that is from inside and from outside, this food residue, and have a priority. Final decision relating to the overall cleaning regimen will have to consider the following thing: identification of the any points in the layout of the plant that may be specially prone to the buildup of the food residue. First of all, what we have to do, we have to identify the point of in the layout of the plant which carry or which build up the food residue, whether these components need to be a dismantled or manual washing, or whether they can be cleaned instead to hand washing. Okay, so what we have to do, either these components are cleaned by a manual washing, or either it is cleaned by a hand washing. That means that using a lower water temperature, but scrubbing and the visual inspection are involved, which lead to the surface really clean. Okay, so this scrubbing and the visual inspection is very important. Now the next is the selection of the best detergent for the task should be completed with the expert advice. See, when we are doing a cleaning, okay, so during the cleaning we have to select a best detergent so that it will complete with the expert advice, because in addition to a variable which mentioned above, factor like available contact time and hardness of the local water can alter a expected efficiency of a selected detergent. Okay, now the next is in general, the cleaning of the static items of equipment, which involve three stages. Okay, so if we talk about the cleaning of the equipment, cleaning of the equipment, then it will lead to a three steps. Okay, the first one is the removal of the gross soil, and this removal of the gross soil are done by a mechanical action in some form. For example, hand washing with the brushes or the use of high velocity jet of the water circulating water. Okay, so the first thing is that when we have to remove our gross soil with the help of the mechanical action, then in that case, the example is that suppose that we have to do a hand washing with the help of the brushes, or either with the use of the high velocity of the jet of water circulating water and the action of appropriate detergent. The next is stage is removal of the fine residue of the food. Okay, so in that case, it may be still adhering to a contact surface or may have been deposited during a drainage of the first wash. Okay, suppose that when we do a first wash, maybe the some residue are still deposited inside the pipeline, or maybe it adhere into a contact surface area, so we have to remove the fine residue in the second stage. The next is that we have to rinsing to remove the detergent residue, because we are using a detergent, so this detergent is remove the food particle in first two step. Now in third step, what we have to do, we have to remove the detergent. So in that case, what we have to do, it may be might hinder the action of any chemical sanitizing agent. Now the next is the option for cleaning summarize our table, which we cover in the next slide, and cleaning in a place, that is called a CIP. CIP means that cleaning in a place is preferred to the option for a large item of plant with a pipe work which is necessary to link into a CIP circuit. The advantages of the CIP are used of the highest temperature compatible with the chemical composition of the soil. Okay, so in CIP what we are doing, we are using a water for the cleaning, and the temperature of the water is high, which compared the chemical composition decomposition of the soil, and the second is your soaring action of the cleaning fluid, which will pass through a pipework at around 1 to 2 meter per second, and the use of the rotating jet or a spray ball, which enable our enclosed vessels to be thoroughly clean as well. It is according to the Romney 1999 and Tamim and Robinson 1999. Now the next is your slight downside to the installation of the CIP system is the cost of the centrifugal pump, which need to provide a appropriate fluid velocity. Okay, so there is a downside when we install this CIP system. The first one is your the cost of the centrifugal pump, which is needed to provide an appropriate fluid velocity, and even the cost of the tank for holding and heating the detergent solution, and the valve which isolate the product CIP circuit, and some level of the automatic control. So all these four things which we discussed, it is related to the cost. That's why there is a downside for the installation of the CIP system. Now the next is your the extent of the automation can, of course, that must be adjusted to suit the complexity of the plant and the level of the investment available. But it is essential that the operative have a visual display which show which tank pipe work are full of product which are being cleaned. Now the next is your this degree of control also make it possible to incorporate flexible cleaning schedule into a normal shift pattern, because it is very familiar to a Gantt chart enable production and cleaning schedule to be manipulated to meet the varying pressure that may be placed on the manufacturer facility and the fluctuation in demand for particular product line. For example, when we need to meet a just in time delivery date, that can be accommodated much more easily if the cleaning of the critical section of the plant is under a CIP or a computer control according to the Tamim and Robinson. So this table show the some of the option for a cleaning stainless steel or other hard surfaces. Okay, so if we have a type of soil that is your carnaceous coagulated protein caramelized or sugar, then it required a high pressure, low pressure, CIP and manual. Okay, then other one is your water soluble amount of soil, if it is high or if it is low. Then open vessels, easy access, typical access, tables and benches, horizontal surfaces, vertical surfaces, enclosed processing equipments, pipework and a tank. So this is all about the cleaning of the plant and equipment. In this lecture, we only discuss about the cleaning and the cleaning process. Okay, how we clean the equipments and the plant. In the next lecture, we will focus on the sanitization process, because when we clean the equipment, then it requires two things. One is your removing of the dust particle, which we done by a cleaning process, or removing of the food debris. But after removing of this or dust or the food debris, we required a sanitization process, which means that we have to we have to eliminate we have to kill the microorganisms or microbial growth which already develop at that area, because this microbial contamination will not decreases by the cleaning process. It can be eliminated only by a sanitization process. So this will be discussed in the next lecture. I hope you will understand the today's lecture, but if you have any query related to this topic, you can ask me in the comment box, or for a further detail, you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp and LinkedIn. And subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or you can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450. Visit our website www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.